Let's go over the worksheet 1.2, solving equations with variables on both sides. The process, we're going to distribute and combine like terms, like we always do, and simplify. Then we want to put all variables on one side and all numbers on the other side, and then we're going to solve like normal. When we solve variables, equations in general, this is true of any linear equation. You can either have one solution. If you get a true statement, all the variables cancel out. We call that infinitely many solutions. And if all the variables cancel out, but you get a false statement, that's no solution. So all those are in play. So you get an answer, no solution, or infinitely many solutions. First part of the worksheet, let's do a quick review. This is order of operations. Remember, PEMDAS, we're going to multiply, divide first. So actually, I start here. 7 divided by 7 is 10, minus 3 plus 5. Everything else is just add or subtract. We're just going to add or subtract. 10 minus 3 is 7, plus 5 is 12. This one, we're just going to add up like terms. So I could add all the x squares together. 2x squared plus 1x squared is 3x squared. And I cut up all the x's together, linear x's. So 4x plus 4x is 8x. And then lastly, we have the 5, the constant term. Next one, we're going to add up like terms. Now let's start with the x's. These are both x's. So I got them up and I get negative 6x. And then let's do the y's, this one and that one. That's plus 5y. And then the constant terms. Negative 5 plus 2 is negative 3. And there we go. Okay, let's get to the actual problem here. So we're going to solve these. Here's my equal sign, put a line through it. Remember, whatever I do to one side, I got to do the other side. Now here, I have a variable on both sides. I want to get variable only on one side. So most of the time, we like to subtract the smaller variable. So in this case, there's only a variable on this side. So we want to move everything to the left. So let's get rid of this 3x here, the smaller variable. So I'm going to put minus 3x, minus 3x. That gets me 2x. Those cancel and bring down to 12. Don't forget the equal signs in between. And we just got to solve this problem. 2x divided by 12. Sorry. So we're just going to divide both sides by 2. And we get x equals 3. 6. X equals 6. Oh, one over here. Same concept, put an equal sign there. Now, I should have two variables, so we have to get rid of one of them. I'm going to get rid of the right one. It makes no difference, but let's get rid of this one. So I'm going to go minus 2y, minus 2y. These cancel out. I get 3 equals 5. That is a false statement. There's no variables left, so it's either true or false. And this is a false statement, so no solution. Oh, I forgot to check this thing down here. So what type of solution we have? We have none. We have one solution. So there we go. Next one, same concept. And I want to get rid of one of the variables. Let's get rid of them. So let's subtract the 6x. And again, they cancel out. But this time we have negative 12 equals negative 12. That's a true statement. So infinitely many. Next one here. Again, we want to get rid of one of the variables. It doesn't matter which side, but in this case, I'm going to get rid of the negative one because it's easier. Right? We're going to add the 2p to both sides. So if I add 2p here, I have to add it here. And we're going to get 5p minus 2 equals, those cancel, 13. And we can solve like normal. Let's get rid of this negative 2, right? I want to put only variables on this side. So we're going to add 2p to both sides. We're going to get 5p equals 15. And we just got to solve. So we're going to divide both sides by 5. P equals 3. And again, we have one solution there. This one down here, let's get rid of one of the variables. So minus 4x, minus 4x. They cancel out again. You get 7 equals negative 2. Not true, so no solution. None. Value of anything, I was supposed to put the answer. So 6. That doesn't have any. That doesn't have any. 3. Okay, let's go on to this one. So same idea. Now this one, before I do anything, let's distribute. 2x plus 6 equals 2x plus 6. Then, so it's 2x, 2 times x, and then 2 times 3. Now let's get rid of the variables. So minus 2x, minus 2x. I get 6 equals 6. That is true. So infinitely many solutions. Okay, so on to the other ones. So here, now, same idea. Let's get rid of one of the variables. I know this one's a bigger one, but there's only a variable on this side. So we're going to get rid of the variable on this side because we're going to leave only numbers. So let's go minus 8x. Those cancel. 7 minus 8 is negative 1x. And then you bring down to 12. Remember to divide both sides? We have to make it a positive x, so let's divide both sides by negative 1. And we get x equals negative 12. And there we go. Remember, if you want, you can always check your work. So that in this case, if I want to check my work, 7 times, just plug it in. I wish I would have checked my work on one that was a little nicer, but I would get negative 84 equals negative 96 plus 12. And then that gets me negative 84 when you add them up. So it does work. So if you want, you can always check your work. Don't forget. Okay, the next one. Let's distribute. First thing I do is distribute this. So 5 times n is 5n. 5 times negative 7 is negative 35. Over here, 2 times n, 2 times 14. So 2n plus 28. Next, we want to get rid of one of the variables. I'm gonna get rid of the smaller variable here. So subtract the 2n from both sides. Minus 2n minus 2. Remember, line it up. Ends with n's. These cancel out. 5n minus 2n is 3n. And everything else stays. Minus 35 equals 28. Now we're just all like normal. Let's get rid of this negative 35 because I want to get that n by itself. So I'm going to add 35 to both sides. I'm running out of space, move it over there. I'm going to get 3n. These are gone. Equals 35 plus 28. That's going to be 3. Carry the 1. Oop, carry the 3. Carry the 1. 63. Then we just got to get n by itself. So let's divide by 3. And I get n equals 31. 21. There we go. 6 divided by 3 is 2. 3 divided by 3 is 1. So there we go. Let's move on to the next one. Remember, first thing here, this distribute. I got to distribute that negative into both of these. So that negative gets multiplied by here and by here. Negative 8x stays where it is. And then we're going to get negative 3x, negative 1. If you don't see a 1, it's a 1 there. Times 3x is negative 3x. Negative 1 times 6 is negative 6. Equals 4 minus x. Right there. And now we're going to add up like terms. So before we do anything else, remember, you want to simplify it. So I can add these two up, and I get, they're both negative, so you just get a bigger negative. You're at negative 8, then you're going to go back another 3. Negative 11x minus 6 equals 4 minus x. Now I'm going to just do a little differently. Normally, I'm going to get rid of the smaller negative, the smaller one, which is actually this one. This one's small, it's much smaller. I'm going to add this both sides. That way I'm going to get a positive x. So I'm actually going to get rid of this one first. It might seem a little weird, but I'm going to get rid of this guy because it's a big negative. So I'm going to add 11x to both sides. These cancel. I get negative 6 equals 4 plus 10x. Negative x plus 11, 10x. And now right here, I got to get rid of the 4 because I want to keep the 10x by itself. So let's subtract 4 from both sides. These cancel. Negative 6 minus 4. Again, they're both negatives. So you're like at negative 6 going back another 4. So you get more negatives. So negative 10, running out of space. Equals 10x. Then we just divide by 10. So negative 1 equals x. Right there. Next one. Again, first thing, let's simplify. So I'm going to distribute this negative 3 to both of these. So I'm going to get negative 3n plus 12. Negative 3 times negative 4 is a positive 12. Leave the 8n alone. 14 plus 3n. Again, next, before I do anything else, let's simplify. Anything on the same side you want to add if you can. So I can't do anything here, but here I can simplify these two. Okay, add them up. So that's going to give me 5n plus 12. And over here it's 14 plus 3n. Now we're going to solve. I like to get rid of the smaller variable when possible. So let's subtract off this 3n from both sides. Probably should put the equal sign down. These cancel out. I get 14 equals 2n plus 12. Now we're just going to solve it. I got the 2n right there. I want to solve for it. Let's get rid of that 12. Minus 12 from both sides. These cancel. I get 2n equals 12. 2. I can do math. And now we're just going to divide by 2. So divide both sides by 2. And you get n equals 1. Now, let's go. Let's do some more. So again, right here we're going to distribute. So we get 12w minus 15 equal sign, 6w minus 33. And again, I like to get rid of the smaller variable first. So I always like to get rid of the variable first if possible. After I simplify. Can't do anything else. So let's get rid of the smaller variable, minus 6w from both sides. Those are gone. I get negative 33 equals 6w minus 15. Now let's solve for 6w. I'm going to add 15 to both sides. I get 6w equals, what is that? Negative 3 plus 15, negative 18. Right there. And then we're going to get the w by itself, so divide by 6. And we're going to have w equals negative 3. Over here, let's do this one. Again, first thing before you do anything else, distribute. So distribute that forward both. So I get 4x plus 36 equals x plus 9. Again, get rid of the smaller variable. So I get rid of this x here. I get 3x plus 36 equals 9. Subtract the 36 from both sides. Probably should put the line, I always forget. I'm going to get 3x equals 9 minus 36 is negative 27. Then we just got to divide by 3. X equals negative 9. Like that. Okay, a few more. Let's keep on going. So next one. Always get rid of the smaller variable. In case they match, that's going to tell you something. This is going to be a special case. Minus 12b, minus 12b. They are gone. I get 9 equals 11. Keep in mind, not true. So if that's false, there's no solution. None. Over here, no. Don't jump to conclusions. Let's try to solve it. I'm going to get rid of this 3x here. So do the opposite. Plus 3x. Plus 3x. Those cancel. I get 27 is equal to 6x plus 27. I want to get 6 by itself, so subtract 27. Minus 27. All right, here's the line. Minus 27. Whatever you do to one side, you got to do to the other side. These cancel. It's not nothing. A lot of people put nothing there. It's a 0. When they cancel, it's a 0 equals 6x. Technically, it's plus 0 here also. So we have this. This is not no solution. I could solve this still. Divide by 6. Those cancel out. I get x equals 0 divided by 6 is just 0. X equals 0. That's the solution. And that's an answer. That's one solution. That counts. Okay, let's do 2 more. Same way we're going to distribute. So I get 6a plus 16 equals negative 5a minus 6. Again, we want to get only one variable, so let's get rid of the smaller one. We get rid of this negative. So we'll go plus 5a plus 5a. So those cancel. I get negative 6 equals 6a plus 5a is 11a plus 16. Now we can solve for the a here. So we'll just get rid of that 16. Minus 16 from both sides. These cancel out. I get negative 22 equals 11a. Now we're just going to divide by 11. A equals negative 2. Over here. So first thing we're going to do is simplify both sides. So here's my equal to sign. Remember, both sides, whatever you do, one side or the other side. In this case, we're just going to simplify both sides. So this negative 3 I get to distribute. So let's get negative 3y plus 3 minus 1. Over here, I can add up like terms actually. I got 4y and a 2y. So let's add those up. I get 6y, and then negative 7 stays, and then equal sign. Now before I do anything else, let me add these two up also. So I'm going to get 6y minus 7 equals negative 3y plus 2. Okay, next, let's get rid of one of the variables. I'm going to get rid of the smaller one. It's negative here. So I'm going to add that to both sides. Whatever I do one side, I got to do the other side. These cancel. 6y plus 3y is 9y. So I get 9y minus 7 equals 2. And then let's add the 7 to both sides. Get rid of it. And I get 9y equals 9. And then we can just divide by 9. And I get y equals 1. So there we go. Okay. Some fractions. I haven't done some fractions a little bit. So remember, the way we do fractions, we're going to multiply by the LCD. So the LCD on this one is going to be a 4. 2 and 4 both go into 4. So I'm just multiply everything by 4. So this gets multiplied by 4. This gets multiplied by 4. And this gets multiplied by 4. I'm going to do it the shortcut way, the long way. I'll show every step. So I'm going to go 4 times 3 is 12. So 12x over 4 minus 4 times x is just 4x over 2 equals 4 times 3 is 12. And then we're going to simplify. 12 over 4 is 3. 4 over 2 is 2 equals 12. And we can simplify a little bit more. I'm going to move this over here. 3 minus 2 is 1x equals 12. And we're done. Let's move over here. So in this case, let's simplify first. Oh, this one might be ugly. Let's distribute 1/3 t plus 6 times 1/3 is 2. 6 divided by 3, essentially. That's what that is. 6 times 1/3, sending us 6 over 3, which is 2. We have minus 10 still, equals negative 3t plus 2. Oh, this might get a little ugly. Let's simplify first. So I'm going to simplify this. So I got 1/3 t. Oops. Let me write that nicer. 1/3 t. Then we have minus 8 equals negative 3t plus 2. Let's get rid of the variables. So I'm going to add 3t to both sides. Okay, and then those cancel out. Over here we have 3 1/3 2. So I could do common denominator. It's probably the way I should do this. this is going to be 1/3 plus 3. So if you remember how to add fractions, you're supposed to get a common denominator. So over 1, that makes this, the common denominator is going to be 3. So multiply this guy by 3 over 3. And I'm going to get 9 over 3 plus 1/3, which is 10 over 3. So this is 10 over 3t minus 8 equals 2. And then we got to add 8 to both sides. Get rid of that 8. Try to get the variable by itself. Okay, I got some space because this one's ugly. So I get 10t over 3 equals 10. Almost done. Now we just got to solve for this. So I got to get rid of this fraction here. So let's do it one step at a time. I want to get rid of the 3 first. So let's multiply both sides by 3. Those cancel out. And I get 10t equals 30. Then we're just going to divide by 10. Now I could have done that in one move if I did reciprocal. But just to show, I'm going to get t equals 3. So all that got me t equals 3. Over here, another fraction. Remember, we're going to do the LCD with a fraction. Now we got lucky again. LCD is just going to be 6. 6 and 3 both go into 6. So just multiply everything by 6. So over here, we're going to multiply top. So I get 30x over 6 minus 12 equals 6x over 3 plus 18. I just multiplied all the tots by it. Now we're going to try to reduce. So 30x over 6, 30 over 6 is 5x, minus 12, 6x over 3 is just 2x, plus 18. And now we're going to solve like normal. Let's get rid of 2x. We get 3x minus 12 equals 18. Then we're going to add 12 to both sides. And we get 3x equals 30. And then we're just going to divide by 3. X equals 10. There we go. Okay. I have a real world problem here. A square and a rectangle have the same perimeter. The side lengths of the square are 4x minus 6. And the rectangle has a length of 2x plus 2 and width of 2x. Find x. Okay, well, there's a simple problem here. So my square has this, that's an ugly square. So there's my square. All these are the same. And this is 4x minus 1. And then my perimeter, my rectangle is 2x plus 2 and 2x. And they have the same perimeter. Now the perimeter of my square, is add all those around, it's going to be 4 times 4x minus 1. And the perimeter of my rectangle is, well, we could do the formula 2 length plus 2 width, or we just add all these up. Now let's do the formula. So it's going to be 2 times 2x plus 2 times 2x plus 2. And these things should equal each other. I really should give you guys more space on this one. Sorry about that. You could do it that way. You can also just do it the old-fashioned way. Just go 4x minus 6 plus 4x minus 1 plus 4x minus 1 plus 4x minus 1 plus 4x minus 1. That's perimeter of the rectangle. Then perimeter of the square. Perimeter of the rectangle will be 2x plus 2 plus 2x plus 2x plus 2 plus 2x. Anyway, let's do more math way. Let's simplify this. Distribute. I'm gonna write it over here because I'm running out of space already. 16x minus 4 equals, that's this times this times this. Over here, let me simplify this here. So that's going to be 4x plus 4x plus 4. This is showing 2 times 2, 2 times 2. I got up like terms, and I'm going to get 8x plus 4. That's what this side is. And now it's the same problem we've been doing, right? Get rid of one of the variables, minus 8x, minus 8x. So I get 8x minus 4 equals 4. Let's add 4 to both sides. 8x equals 8, and then we're going to divide by 8, and x equals 1. So there's my answer. X equals 1. Over here, oh, and I have a whole other page. That was close to being over. Error analysis. Students solve this by dividing both sides by 2 and getting x plus 3 times equals x plus 3. They wrote x equals 3 as the answer. Explain what x plus 3 equals x plus 3 actually tells you about the equation solution and state the correct solution. So actually, we're only dealing with this part of it. They did the right thing. They divided both sides by 2. That works out perfectly. Their only question is, what's going on here? So x plus 3 equals x plus 3. If we subtract x from both sides, we get 3 equals 3. So this is actually all real numbers, infinitely many solutions. So that's what's going on here. So they should get infinitely, because these are equal to each other. So no matter what you plug in for x, it's going to work. So infinitely many solutions. That's what's going on there. Okay, a few more. So let's distribute. So to this one, we're going to distribute. So this distribute, I get 6x minus 12 equals, I'm going to add up like terms here. Negative 8 minus 4 is negative 12. We're at negative 8, and we're going to go back another 4. So 6x minus 12. And look at, they're the same thing again. So I'm going to get infinitely many solutions again. But just to show you, let's actually do it. I'm going to minus 6x for both sides, get rid of the variable. These cancel out. I get negative 12 is equal to negative 12. So infinitely many solutions. Remember, if it's a true statement, it's infinitely many solutions. False statement, no solutions. Solution. Over here, it looks scary, there's decimals, but look what happens. Minus 2.5x minus 2.5x. I get 4 equals negative 1. That is false. 4 does not equal negative 1, so no solution. None. Okay. Over here, it's the only one here, I guess. Let's distribute. So I have 7 minus, let me show them, minus 6x, negative 2 times 3, and then plus 2, negative 2 times negative 1, equals 4x minus 1. Now remember, before we do anything else, let's simplify if we can. I could add the 7 with the 2, and I get 9 minus 6x equals 4x minus 1. Now with this, we're going to solve. I'm going to add the 6 to both sides. Get rid of this negative 6. So plus 6x plus 6x. Those are gone. I get 9 equals 10x minus 1. And then I just got to solve for the 10x. So let's get rid of that 1. Minus 1. Let's put 1 on both sides. Like we get 10x. Oops, sorry. 10 is equal to 10x. So divide by 10. 1 equals x, or x equals 1. Either way works. So we have one solution there. Okay. Last one, I believe. Justify without fully solving. Predict whether each equation has one, none, no, or infinitely many solutions. Explain the reasoning, constant equation. So they want to decide, is it, without solving it, we're just going to look at it. Is it one, none, or infinitely many? So A here, I know the 5x are going to cancel out, and I'm going to get a false statement. So this is going to be none. Right? 3 does not equal 5. 7, sorry. So the x's are cancel out, and they're not going to work. So none. Over here, the x's will not cancel out. Right? If I subtract the reaction from both sides, I'm going to get an actual equation. So this is going to be one solution, because the x's are not going to cancel out. X's will not cancel out. C is a little funky. It's 5x plus 7 equals 5x plus 7. That's the same equation. 5x plus 7 equals 5x plus 7. So in this case, you're going to get like 7 equals 7 when you cancel those 5s. You're going to get a true statement. So infinitely many. Okay, there we go. That's the video.